So flags. Flags are simply variables that we set so that for a given session, our maxima behaves in a certain way. So let's say I use this function, it's called expand. And expand takes one argument. So I'm going to put in, let's see. Orb plus cut square now enter and I get cat squared plus 2 bob cat plus bob squared, right? So if you did a plus b whole squared, this is simply a squared plus 2ab plus b squared. And you can see that it starts with the letter C and it goes towards B. The first flag is powered disk. And it's logical. Powered disk tells us it is set to false. So I can change that flag by setting powered disk to be true, because the flag is logical. Patience, my young Padawan learner. No one got that? Yeah. We got it. Okay. So what just happened after I said powered disk?
Switch the order.
It switched the order in which the expression is presented to us. So last time it went in descending order backwards, now it's going forwards. So bob squared plus 2 bob cat plus cat squared. Are we clear? We all know we use exponentials. So e raised to or e raised x. If you want to have an exponential function, regular e, natural number e, so you have to use the percent sign. So percent e raised x. And that would mean the function e raised x. If you don't use the percent sign, it's just another variable, e. But of course, if I simply typed percent e, I simply get percent e. But what is the value of percent e, or e in general? What is the value of that natural number e?
2.71828.
2.71828. But it's not showing me 2.71828. Our hearts are broken. The reason being, Maxima is a computer algebra system. It is not like R, which evaluates numeric values. So how do we get the value of percent e? You can use bfloat, percent e. Good. And there it is, at 2.71821828. Good.
What's that? B. Oh,
Good question. So the B0 at the very end simply means 10 raised 0. It's in base 10, 10 raised 0. Still, too many digits. But before we move on to another flag, if you have to take a guess, how would we get a pi? Pi. Pi. Just pi.
What's the float in that? For the Greek
Didn't
letter?
know.
Percent PI.
Huh?
Percent PI.
Percent PI.
B float percent.
Huh?
The B float percent BI.
B float percent I. Good. Now, you've got to be careful because Maxima can use Greek letters also. If you want to toy around with Greek variables, you can do it. You can simply click and Maxima will simply use Greek letters. You can use alpha, beta instead of A and B. Entirely up to you. So here it is easy. With R, it's a bit complicated. So it's a give and take trade-off between the two languages. Now, is pi a rational number?
No.
No, but I'm going to force rat. Well, let's go ahead and save that value to u. And rat u. It's just obviously giving us a fraction, right? So you can take a decimal value and convert it to a fraction, but then again, it's just an approximation. This is the best that we could get.
Why is the B uppercase now?
It should still be 10 raised 0. I wonder why it is uppercase. That's a good question. I don't know. We have to Google that. Still in base 10, so I don't know why it went to uppercase B. I'll look it up.
So is that the new 22/7? Remember?
I mean, would it reduce to 22/7? Kind of doubt it.
Oh, it doesn't automatically reduce.
No, there is an expression to reduce them. I'll show that to you later. Now, there is another flag. It is FP prec. FP stands for floating point. Prec stands for position. Every machine that you have has something called a machine position. You cannot go below the value that the machine has, and you cannot go above a certain value that the machine has. So we could have more decimal digits, but I can truncate the number of decimal digits, and perhaps I just want 4. So my floating point simply means decimals. The position is just 4. And if I do B float percent pi, I only get 3.142. And if I did percent E, $2.718. So it's not just giving us decimal digits, it is actually giving us significant digits. So FP prec, 4 significant digits, so 3.142 and 0. Good so far? So if you want a floating point number for pi or E, you've got to use B float. And FP prec would help us set the number of decimals we need. The moment you close Maxima and open it back up, things will change. Let's see. There is another flag, which is power disk. And as of now, it says true. Let's type X raised. Did we define X? I don't think so. Kill it. X raised -2. It represents as 1 over x squared. But if I set power disk to the false, it still gives me 1 over x raised -2. Now, let's do 10 raised -2. I get 1 over 100. Oops. And 10 raised -2 still is 1 over 100. So the power disk flag is used in terms of expanding polynomials and how powers should be displayed in terms of expansion. So if I did expand x plus y, hopefully I didn't define this, p plus q raised 6. You know, back then you sit and FOIL, p plus q raised 6, but Maxima does it for you. And if you expand p plus 6, this is what you will have. Is my power disk on?
Yes.
Okay. Let me try power disk false. I think I am using the right flag. P plus q. Raised 6. What just happened?
The order of the terms are reversed.
The order of the terms are reversed and the powers are changed to here. It went in decreasing powers, there increasing powers. So why did I start with 1 over x squared, 1 over 10 raised 2, 1 over 100. So one may think power disk will affect these powers. That's not true. Power disk will affect powers in a polynomial. So if you want to express exponents in a different way, it is expt disk. No, we may have to Google this. So there is another flag, exponent disk, x plus y cubed. We have y cubed plus 6xy squared plus 12x squared y plus 8x cubed. That doesn't sound right. What happened? Is that x plus y cubed?
No.
I mean, if you expand x plus y cubed, would you get that?
Wouldn't get 8x cubed.
We're not going to get 8x cubed. What
Does
happens?
that mean x is equal to 2x?
It simply means that we have a different assignment already. So perhaps we will kill everything. And now it works. So have y cubed, xy squared, x squared, y is my power disk on, off? False. Going to set it to true.
Look it up. I think it's Edith.
Huh?
I think it's Edith. The exponent.
Is it Edith?
I looked it up. I think that's what it's called.
Oh, crap. do it again here. So in both cases, we're not able to or we are not arranging in terms of the letters X and Y like we did earlier. We're doing it in terms of powers, right? Even though it is X, Y, I move this term over here, that term over there, so that the powers of X decrease, right? So another example, let's just say I have X raised 16 plus X raised 24 plus X cubed. And I end up getting X cubed, X raised 16, X raised 24. And my power disk was true. If I made it false, it will switch the order and give me X raised 24 plus X raised 16 plus X cubed, right? So once again, it's just switching the order in which the powers are displayed, unlike what we did at the very beginning. We do it. Oh, we actually did it at the beginning. But is it making sense? How is it, Chris, did you say E disk?
I don't know, it's, I tried it, it wasn't working.
It's percent E disk flag.
Oh, it's E disk flag.
Yeah, I haven't been able to get it to work with E.
Okay. So right now it is false.
Oh wait, this might just be only for, like the E, I think might be only for the function.
Only for the E values.
Because it doesn't work on X when I did E disk flag.
Exactly. There is another one. I think it's EXPNT disk flag.
EXPT disk flag.
Do we have EXPT disk flag?
I'll try it.
So right now this is set to be false. If I did E% E raised -3, it just says percent E raised -3. But if I turn that flag to be true,
Guess it, found it. It worked.
percent E raised -3 is expressed in a different way as a fraction, 1 over something. So the percent E disk flag simply converts that negative exponent and puts it as a fraction.
EXPD, like EXPT disk flag.
Oh, I just missed this part. So
Is it okay? Can you put a pin in there? Yeah. EXPT disk, so it's 5. See. Yeah, it's true.
there shouldn't be percent.
Yeah.
Right now it's true. So when I do X raised -2, I get 1/x squared. If I turn that off by setting it as false, X raised -2 will display as X raised -2. Does that make sense? Same thing you can do with Maple also. Good. So flags pretty much help you express expressions in a certain way. And all of these words are reserved keywords. You can't use them because they are predefined. You can't use them for other purposes than what they are meant for here. Good. Now, I am going to go over something called a lambda function. A lambda function is simply a one-liner function. Not every programming language will have lambda functions. Maxima does, Python does, R doesn't. So what is it? A lambda function, again, it's a one-liner. So I can have, give me a name, well, I'll call Bob. So we define it, Bob, colon, lambda, because in Maxima, any definition, we say it using a colon. And the first argument that you pass to a lambda function would be a list of variables that we need to define. I'm just going to pick A and B. The second argument is that you evaluate a bunch of expressions. So let's see. What should we do? A is A plus B, and then comma print Wally. They actually didn't. Surprising. So A comma B, we define A plus B assigned to A, and then print Wally. To access the function that you just defined, we have to pass values for A and B. Give me two values. I'll use it for A and B.
2, 4.
2, 4. A is 2, B is 4. What just happened? It printed the very last statement. Do we believe that it executed this statement, A plus B, and assigned it to A? So in other words, is the value of A 6? No. No. So just like a lambda function, a block function, this has local scope. Now what would happen if I take the same lambda function and I'll call it Bob1. Don't forget, oh, you can define it as Bob1 too. It's perfectly fine. This time, instead of having two separate arguments, I'm going to put open paren, close paren. So this is for the lambda function, and I'm going to type the same arguments that we did or same statements. Only this time I'm sort of putting them together, organizing them, and leaving them within parentheses. It's still run. To access the second lambda function, what should be used? Let's pick two numbers for A and B.
6 and 7.
6 and 7, okay, so how would we type that in?
Bob_1, It's common sense.
Good. A, still A. The only difference here is I simply organize stuff properly. So later on, when we do loops and such, we have to use parentheses at the right spots, or else you would get errors. So I highly recommend that you get used to the idea of having parentheses and organizing statements. Good. Could we define a lambda function within a lambda function? We absolutely can. Just like a block function, we can define lambda function within a lambda function.